Hi, today we are looking at section 5.3, which is standard deviation. Now, deviation is the difference between a data value and the mean of a set of data. Standard deviation is a measure of the dispersion of data values in relation to our mean. So low standard deviation indicates that most of our values are close to our mean, so close to our average value, while a high standard deviation indicates that values are scattered farther from our mean. So for this, we have our mean formula, which we've already gone over. So our mean is equal to our sum of our data points divided by our amount of data points. Our standard deviation is represented by this symbol here, and it's a square root of the sum of each data point minus the mean squared and then divided by how many data points we have. Okay, so we will look at an example. What is the mean and standard deviation of the following numbers? We have 60, 54, 56, 48, 61, 57, and 61. So our first step will be to find our mean. So we know our mean is equal to the sum of our data points divided by n. So we'd have 60 plus 54 plus 59 plus 56 plus 48 plus 61 plus 57 plus 61 divided by, we have 1, 2, 3, 4, 5, 6, 7, 8 values. So that gives us, we add all these up, 456 divided by 8. So we have a mean of 57. Now we want to get our standard deviation. So our standard deviation is equal to the square root of the sum of each data point minus the mean squared divided by our number of terms. Okay, so our first data point was 60, so we'll have 60 minus our mean of 57 squared. Then we go to add our next one, so plus 54 minus 57 squared plus 59 minus 57 squared plus 56 minus 57 squared. And we do that for all the terms up here, and then that's divided by 8. So we'll try to fit all these in. We may have to extend this square ways over. Okay, so we have plus 48 minus 57 squared plus 61 minus 57 squared plus 57 minus 57 squared plus 61 minus 57 squared. So I'll start by simplifying that numerator. So that numerator ends up being 136 divided by 8. So our answer is going to be the square root of 17. So this has a standard deviation of 4.12. Now, if we're doing standard deviation of group data, we will have to change up a couple things to help us so that our calculation isn't super long. So in order to get our mean, we'll multiply each frequency by the midpoint of an interval, then add all those together and divide by the total amount of entries to get our mean. So we have this. We want to find our mean. So I'm actually just going to extend this table a bit. Now, like we said, we're using the midpoint of our interval. So 3 to 5's midpoint would be 4, 5 to 7 would be 6, 7 to 9 would be 8, 9 to 11 is 10, 11 to 13 is 12, 13 to 15 is 14. So here we're just going to multiply this by our frequency. So we have 4 times 7 is 28. Then here we have 6 times 11 is 66. Then we have 8 times 16 is 128. 10 times 19 is 190. 12 times 12 equals 144. 14 times 5 is 70. Okay, so now we will add this column up as well as we'll add this column up. So we've got 28 plus 66 plus 128 plus 190 plus 144 plus 70 gives us 626. Now this is technically our sum of x. When we add this up, we have 7 plus 11 plus 16 plus 19 plus 12 plus 5, and we have 70. Now, technically, that is our n. So when we're getting our mean, it's the sum of x over n. So we have 626 divided by 70. And that gives us 8.942. Now that we have our mean, we can get our standard deviation by subtracting the mean from the midpoints. And then square, take that number, multiply it by our frequency, add them together, divide by n, and take our square root. So we already have our frequency times x. This was essentially this column here. That being said, we most likely will not be using this. We already just had that. We said that our mean was 8.942. Our n was 70. So I'm going to just add a couple more columns onto this to help us, because it's probably easiest if we do it in a table and don't write out as one big long formula. So in this column, we will do our x minus our mean squared. So our midpoint for this one was 4. So this one we would essentially have 8.92 minus 4 squared. Oh, sorry, that's 8.942. And let's just do that to, let's say, 1 decimal place. So that gives us 24.4. We'll do the same thing with this one. So we have our data point, which is 6, minus 8.942. And squaring gives us 8.7. Next one, we have 8 minus 8.942. Squaring that gives us 0.9. Next one, we have midpoint of 10. So we've got 10 minus 8.942. And then square that gives us 1.1. Next one, we have 12 minus 8.942. Square that gives us 9.4. And then this last one, we have 14 minus 8.942 and squared. And that gives us 25.6. Okay, so these represent those data points when we expanded out our standard deviation. So for each one, we're at x minus our mean and then squared. However, because this doesn't occur once, but occurs 7 times, when we are adding in, it's the same as adding this 7 times, which is the same as 7 times this. So this next column will be our frequency times x minus our mean squared. So if this one had a frequency of 7, so we have 7 times 24.4 So that gives us 170.8. Next one, we had a frequency of 11. So we have 11 times 8.7. And that gives us 95.7. Next one, we had a frequency of 16. 16 times this of 0.9 gives us 14.4. Next one, we have a frequency of 19 times 1.1 gives us 20.9. Next one, we have a frequency of 12. We're multiplying that by 9.4. And that gives us 112.8. Next one, we have frequency of 5 times our 25.6. And that gives us 128. Now what we'll do is add up this here. And that gives us 542.6. Now essentially this here is going to be equal to essentially our sum of x minus our mean squared is this. So when we have our standard deviation is equal to a square root of the sum of x minus x naught, or sorry, x minus x bar squared over n. We can substitute our values in. So we have equals the square root of 542.6 divided by our number that we had here, our n value of 70. We'll take the square root, and that gives us 2.78.